Well, there's a very important role of science in the discussion of climate change in general. Science is looking for better understanding of our natural system in this case, how the climate works, how it behaves, and our ultimate goal would be able to predict behavior well. So the process is you develop a hypothesis, you test your hypothesis, you get data, you evaluate it, you refine your hypothesis, and knowledge is improved. And over time, you get better and better and better, and our ultimate goal in the case of climate change or many environmental sciences is to be able to predict change or behavior in the future. And when we can do that well, then we're providing a great service, but we're understanding these systems in a fundamental way. Well, I think the big picture is fairly easy to demonstrate. I mean, you can go to historical sites in the Mediterranean and see that they've been flooded, Roman ruins and things like that. I can certainly take you 15 miles off the coast of South Carolina and you can see cypress stumps sticking up out of the bottom, and we're all familiar that's not where they grow, and they're now in 20 meters of water. So that scale of change we're pretty able to convey. It's the time scales of those changes and how much of it is related to natural behavior and how much of it are we modifying from human action. And that's where you start getting into the details and the complexities, and it makes it a little more challenging. Well, I mean, science is by nature a process where you challenge the information. I mean, you do your study, you submit your results, it goes out for review, and people analyze it and try to determine if it's appropriate, if the conclusions are supported. So there is that kind of challenging nature within science itself. And it's also always evolving. And so there are different schools of thought. You may have people looking at climate change from an atmospheric standpoint, and they're atmospheric scientists, or they may be looking at it from the impacts, or somebody that looks at coastal erosion patterns or things of that nature that are more applied. And they're all tied together, and they're all looking at it from a different direction, but it is ultimately a system. And so when you look at the totality of it, it makes it much more complex. The other problem is that climate change is a global phenomenon. That climate change is a global phenomenon doesn't mean everybody gets the same deal, right? Change happens and kind of plays out regionally, and there's lots of feedbacks within the system on different temporal and spatial scales. So you could be in one area that has not been getting a lot of change, saying this is not happening. You can be in another area that is experiencing a lot of change and going, anecdotally, I perceive it happening. And so there's a lot of that kind of complexity within the system that influences, I think, people's perceptions. Well, certainly the kinds of things you might expect to experience in South Carolina, and certainly we along the coast are familiar with the term low country. It is low elevation-wise, and so changes in sea level we are particularly vulnerable to, because we are so low, and a small change in sea level can be a very large change in inundation and in the land surface. And we've seen these changes over time. There's long historic charts and maps where you can see areas that have changed over time. But that ultimately is one of our biggest concerns, because you're changing the water level. That means where your groundwater table is draining to, where your rivers are draining to. You're seeing things in your communities such as the regional stormwater drainage. Where is this material water going to? It's ultimately going to the ocean. Here in the coastal zone, we hear a lot on the news, there'll be flooding in the usual areas at the time of high tide during this rain event, because the water level is a little bit higher. And I think if you've lived along the coast for a while, you may have perceived or noticed that these things seem to happen a little bit more frequently over longer periods of time. So it's kind of creeping up us in that regard in terms of water levels. The other things that are really important to us will be one of the projections for the changes that we're seeing in the global climate is more intense rainfall events. And I think one could make a case, not statistically arguing this at the moment, but just in the last few years, if you look at the event we had here in South Carolina, kind of historic flooding of this funneling of moisture in that corridor up through Columbia, and the amount of devastation that happened in that regard. And we've seen that event again in Maryland, and then recently in Louisiana, and Houston, and in Iowa just the other day. These things are happening, and they're happening more frequently. And we're not really prepared for those kinds of events, because they're a change from what we're used to in our weather. Well, the response of people in different age groups, is a complicated effort. I think if you went back to people that were comfortable in say the 60s when the space program was going on, I think there was a greater belief in science at that time, and you saw all the things that occurred in that time, and there's been a bit of a general degradation in the belief and appreciation for what science can bring to the discussion that's just been happening over the years. I think some of that, I think we may take ownership of that problem in the scientific community. There's been this expansion and trying to work through very complex questions and problems, so that process evolves and there's a lot of debate, and it leaves room for someone that may not be into the intricacies of that debate to see different sides being played out and say there's not a consensus, when in fact there actually is in the big picture. It's the details that are getting argued out. So I think there is a little bit of a difference in generations, but it might be bimodal. It might be there's an earlier group that was familiar with the space program, and then there's another phase that came through, and then younger people are familiar with, they're just trying to absorb knowledge. So I think they're interested in, although truth be told, we've had groups come in from other countries that are same age groups, and question was asked. One was two high school classes, one from South Carolina, one from the country of Denmark, what their perception of climate change was. And surprisingly, the vast majority from South Carolina said they did not believe in climate change, and the vast majority from Denmark said they did. So there's clearly a cultural difference besides just chronological. Well, when you start talking about resiliency, you really have to start considering the scale. Okay, so we've had some experiences. It was a long time ago when Hurricane Hugo came into the coast, and that was a significant storm, but it really hit north of Charleston. So Charleston really didn't get the large impact of it. It was devastating, but it didn't get the force that it could have if the storm was further south. And here in the Grand Strand, we had the same surge that Charleston had, about 13 feet or so. We didn't get it, but there was a lot of devastation and impact that was up here. I don't think we're any more prepared for a Category 4 or 5 hurricane than we were then. I mean, that to some extent we've made a lot of changes. Building codes have modified. The structures are more rigid. There's a lot more commitment to renourishment, but that's not going to address these larger events. So the smaller kinds of scales of change you're seeing in terms of changes in infrastructure, how we're dealing with drainage. The state has been committed to renourishment as a means of combating loss of beach sand, both from natural processes and in long-term horizons and sea level. And we've largely been able to hold the line doing that under the rates and pressures that we've experienced. The question comes, if those rates and pressures accelerate or become significantly higher, will what we've been doing be sufficient? Well, I think the important message to come through is that climate change in and of itself really isn't isolated to the realm of science. It's overlapping interest, and there's lots of things that we try to develop responses to and policy for as a society that we try to manage and do effectively. Some of that may be related to energy policy, or maybe related to economic development or environmental policy. All these really overlap quite a bit. And there's a good need to try to integrate our approaches. We don't want to be working against ourselves, where we do one thing with energy policy and then we have another thing going on in environmental policy. So that's a tough discussion to have, but it's an important one to have, because it ultimately is a matter of cost. These events that we're having, if they keep happening with more increased frequency, they're very expensive. Someone's paying for it, and there's a lot of repercussions for that. When they talk about the issue of resiliency earlier, the idea if you could be more effective in planning in advance rather than responding to the event, we could potentially save money. So that's the goal in trying to get better understanding of how it works, plan and modify the system before it's impacted to both reduce the interruption to society, but also to reduce the long-term cost. Well, I think it goes on a good bit, but to take it to an end member type of argument, it's a question we pose to students quite a bit. If now we were to start to develop our infrastructure, absent of all the things that are in place right now, where would you put things? And you have all sorts of rationale and reasons why you would put things in various places. The reality is the system's changing all this time, so it's a matter of time. You know, if you started a clean slate here along the coast and you built X, number of feet back from where we are today, it's a matter of, with rising sea, that in Y number of years you're going to be in the condition we are today now anyway. So, this idea of resiliency may be as much as maintaining the status quo as long as you can until you have to make a fundamental adjustment. You do see lots of communities on a local scale, but certainly on a state scale, that are responding differently. And recent policy actions in the state of New York were requiring planning for infrastructure and future improvements to infrastructure to be thinking about a 2-meter rise in sea level. They've also then committed to a 50% renewable energy portfolio in their energy consumption patterns. So when you look at that kind of behavior, why are they doing that? Well, they recently had Hurricane Sandy, and it was a big impact. They knew the big one was going to come. They see all the projections when a big storm comes in, there'd be all this water on the runways at Kennedy Airport, but hadn't happened, and then it happened. And it wasn't even the big one, and it was lots of money, lots of interruption, and so they might be a little bit more sensitive that I don't want to have to experience that again. And it might be worth, as we're looking forward, to get ahead of the curve while we're having to make infrastructure changes anyway. Well, you see some of the scenarios that are out there. I mean, if you just look at what came out of the IPCC reports, in the past, the baseline was going to be a significant rise over the next 100 years or so on that time frame, regardless of any anthropogenic effects. The arguments that there are anthropogenic effects, we're seeing changes that are happening. It almost doesn't matter until we get an energy policy. What we do along the coast is that the waters are coming up. They're getting warmer. Things are changing. You're seeing South Carolina or southern fish assemblages up in the Gulf of Maine that hadn't been there before. That's changing the system. You might expect similar kind of pressures on our system from things that might be more common further to the south than they are here at the present. But in an area that's called the Low Country, regardless of what size of rise you want to project, we're going to have inundation issues. We're going to have troubles with drainage. We're going to have troubles with waters backing up, water tables backing up. It may start changing this, how soggy some areas might be in your yard, for example. You might see that. I certainly see that in my yard happening. But those are the kinds of things that might be driven in the future. We actually are very engaged in these issues. As our role has evolved over the years, we became very involved in bridging between basic research and applied research. We do a lot of work with communities, certainly in this region relative to water quality. The Environmental Quality Lab has been working with the counties and the cities dealing with issues of stormwater drainage and the water quality effects that are in the offshore. They were the group that found the hypoxia problems that are off the coast and tracked how that's been behaving. And it's stimulated a whole lot of other science by a lot of other people to try to understand why that happens and what we might be able to do to modify that. For a very long time, we've been involved in coastal erosion types of studies. Very early on, developed a program through OCRM and the South Carolina Sea Grant and the U.S. Geologic Survey to get the kinds of long profile data to talk about the changes that are happening in the system. It actually was data that would be involved in the application of the Beachfront Management Act over time, was where the jurisdictional baseline gets changed every 10 years when that was the prevailing direction within that act. That's where the data was developed and came from. Partnering with the Corps of Engineers, we worked over a number of areas with the U.S. Geological Survey in doing fundamental framework mapping of the underpinnings of our coastal systems and trying to understand how that affects the coastal response to various drivers. those kinds of data sets are also the maps that are available to start considering where your sand resources are for renourishment. They're also the kind of the baseline that you start to look for essential fish habitat in places you want to, these essential fish habitat locations, places you'd like to avoid impacting as you utilize, say, sand for renourishment, or you're building a wind farm or anything else, and other uses of the resources out there. So that fundamental mapping and tying that, trying to understand the basic behavior, but then turning that into the applications for the community and the state, I think has been a valuable role. I think we've also been very successful in maintaining ourselves as an objective, science-based organization. We really try to preach that to everyone involved, that we can step aside and have our personal opinion, but our immediate role is to provide the best science available for society to make decisions, and to recognize that those decisions are not singularly scientifically based. There's legal issues, there's economic issues, there's historical issues, there's culture issues. Very complicated making public policy. But getting the best science available into the mixture is very important, and I think that's been a success in the sense that we do get a lot of calls from the local level as well as at the state level and the regional level, for sure, and occasionally on the national level. Well, I mean, the challenge is if you were to fly along the South Carolina coast right now, all right, you would see areas that are not eroding very much. You would see areas that are eroding up to many tens of feet per year down in the Cape Romaine area. So there's a lot of variability in how the coast is behaving under relatively the same conditions. Now, if we start raising water levels and changing the drivers, we're not going to get everything to react exactly the same. It's going to be complicated. But you can certainly go to places now that are experiencing the more pressing results of the existing forces, inundation, erosion, lots of rapid movement back of the coast. You're seeing areas where homes are being undermined or being lost. I mean, that's already happening, and so you might expect that, just like the statement before about more flooding at the time of high tide. Those kinds of areas are going to just get a little bit wider, a little bit more pervasive, and at relatively low rates, it will kind of creep up on us. More accelerated rates, it will come a lot quicker and a lot further.